Hi, this is Artem with F1 Group, and in this video, I would like to show you how our scheduler assistant works. It's a non-technical demo and also a very simple implementation of the scheduler assistant. Why does a scheduler need an assistant? Well, this goes back to how trucks are utilized by logistics companies. Our client has a fleet of vehicles. Of course, it is a goal to have those vehicles on the road and transporting cargo fully loaded 100% of the time. But unfortunately, this is not the reality for any of the truckers out there. So it's always an ongoing struggle to fill the available trucks. First of all, have them on the road, and secondly, achieve the full truck load. So imagine that our company A has recurring customers, ongoing orders that take up to 85% of their available capacity. And the remaining 50% at any point in time, they have to allocate on a spot basis. So the scheduler sits there in the office of the logistics company, and they are working with the freight exchanges. We have three specific examples here: CourierNet, Timocom, and TransEU that are popular in Germany. However, there is a bunch of various alternatives out there, and many of those are regional solutions. So the scheduler goes onto those freight exchanges and looks for orders that match the available vehicles that they can see from telematic solutions or fleet management solutions such as Webfleet. And then they use internal tools such as PTV to calculate routes and prepare bids for those open orders to hopefully win some orders in the market. And finally, the scheduler uses communication tools, just writing emails, WhatsApp, or Skype to communicate with the customers that they find on those freight exchanges. So let us have a look at the apps that the scheduler is working with. So Webfleet here is a solution that shows us which of our vehicles are currently available. We can recognize that by those green dots right here. And as a scheduler, it is our job to find orders for those vehicles. So let's start with the first one. It's parked here in Pirmasens in Germany. So let us copy that address and go to CourierNet, which is a local freight exchange. Let's apply a filter to see only those orders that are in the, say, 50-kilometer vicinity of that vehicle and that match the vehicle type that we have here, which is a 7.5-ton truck. So we run a search and that comes back empty. So that tells us that on this exchange, we're not going to find anything for that truck. So we have to go on to another exchange and have a look here. About this one. So the second vehicle returns a bunch of results. And we have to look at each of those results and see if it makes sense for us to bid for that order. So this one is on the 4th of June, which is 2 days away from now. So it's too far away. The second one is also on the 4th, the 7th. So it's all pretty far in the future. Unfortunately, nothing for us here. Okay. So the third one actually has an order that is to be picked up today, but it has to be delivered in 2 days. For 230 kilometers, that's a bit of a waiting time. Okay, it's all too far away in the future. And again, for we have to loop through the various exchanges now. And Timocom is actually a larger one, but I don't have the access right now to show you how we'd go about that. But again, you are going through a bunch of orders here and on this little map and seeing if any of those orders actually make sense for your vehicle. So let's give it a go with the last one here to hopefully find something that works for us. Doesn't look too good, to be honest. No, it is all not promising at all. So unfortunately, I've just spent like 5 minutes and looped through this exchange here and haven't found anything. If I did find an order that would make sense for me, I would have to check it against a series of criteria. So can I take this order based on weight? So can it fit into my truck? Based on volume, based on length, and based on the type of cargo that is being transported. If it's all a fit, then I would need to calculate whether the distance to be traveled here actually justifies the expense of driving my truck to the loading point. And I would use a route calculating solution there, and PTV or Google Maps in this case. So for example, to calculate whether my vehicle here is an acceptable distance away from the opening here. This is what I have to do. So run this check. I see that it's a 79-kilometer distance to travel for a 230-kilometer order. So that makes 0 sense. So this again eliminates an order for me. So we've spent several minutes now going through that, and you realize that it's really just a waste of time because I haven't found anything. And if I did find something, then I would be faced with a question, do I spend more time looking? Perhaps there is a better order out there that I could take, or should I just bid for this one? And if the customer accepts my bid, then I'm bound to fulfill that order. So a lot of time invested, and if you want to achieve a better result, you have to put in even more time. So let us have a look at what this workflow looks like when using a scheduler assistant. In this particular implementation, the bot is triggered by an email that we're sending. So here we go. Let me send an email to the bot's email address with fill current capacity in the email subject. Out it goes. And now basically we can do something else. We can call a customer, or we can go take a coffee or call a driver until we get the response back from our bot. Now, let us have a look at the order details that we get here as a result of our bot's work. And this is entirely configurable. It can be sent to you as an email, or it can be posted to your intranet or whatever. This is very flexible. So we have the vehicle details, we have the bid estimate, and the contribution estimate. So this is really where the value added has taken place. So the bot in the background has worked through a bunch of various factors, including the weight of the cargo, the volume, the distance to be traveled, the time that it takes to fulfill the order, the road tolls, but also the idle cost. So expensive visit to drive our truck to pick up that order in the first place. And if the driver has to wait for any extended periods of time, either pick up the order or offload it. This is all calculated according to a predefined formula that's can be different for any business. And then there are all the supporting details to that order so that the scheduler can pick up the phone and get in touch with the customer, bid for that order, and that process can be supported by the scheduler as well. So for example, we can configure it to show a says submit a bid. We click on that link as a scheduler, and then for example, a pre-written email pops out to the contact details that are indicated in that order on the freight exchange. We can then have a final screen through that email, check that everything makes sense, make sure that the vehicle is actually available, and then send it off. So this long process of going through various exchanges, looking at various orders, calculating, and then discarding your results when they don't make sense, this is entirely automated here. So the scheduler can actually focus on thinking about orders that make sense, about communicating with customers, actually negotiating with the customers, because if we see that this has to be picked up very soon, then probably it's an express order which the customer might potentially be willing to pay up for. So again, increased efficiency, better use of schedulers' time, etc., etc. But all what this translates into is more revenue for the logistics company. So let's have a look at what's happening under the hood. As we were waiting for that email to come back from the bot, what was actually going on in there? So here you see the graphical interface of the bot. It's low code, so you can push the buckets here. You can open them like this. You can go in there and define whatever you want to achieve there without actually writing any typical code. So it's very easy to handle. We start with a trigger. So the bot is listening to its email inbox and waiting for an email with a specific subject line header. So when we wrote in there fill current capacity, it recognizes what we want to do, and then it initiates a sequence of steps. So getting exchange orders, getting vehicle availability, and running the matching algorithm all are executed consequently. In each of those steps, a modular approach is used. So first of all, a task bot is initiated that gets the orders from CourierNet. Then we get the orders from Timocom. Then we get the vehicle availability through the API of Webfleet. Then we match those entries and get any supporting details that we need to calculate their profitability. And finally, we put the output in an email. So this is what happens there in the background as we're waiting for that email to come back. Now, let us run the bot to give you a feeling for what it actually looks like when it's triggered. The only step that you'll actually be able to see on the screen here is getting the orders from CourierNet, because this is the only step that's actually being done through the user interface. In other words, when we can avoid mimicking human actions to achieve the results that the bot needs to achieve, we do that, and we use the so-called APIs, or application programming interfaces, that let the bot speak directly to the applications that are being automated, and it's just less error prone. And if something changes in the interface, that's not affected. However, if APIs are not available for one reason or another, either the provider doesn't offer them, such as in CourierNet's case, or for example, when the vendor doesn't let you use their APIs for some reason, it's not a problem. The bot can always work with the same user interface that a human would otherwise work with. So let's go ahead and start the bot. So you see it looping through hundreds of orders here on this particular exchange. Now it's doing the work in the background, looping through the exchanges and other programs that can be connected through the APIs. And we will be getting the email from the bot shortly with the new results. So there we go. It took the bot about 30 seconds to get and analyze all that data and to prepare the recommendations. And we're actually limiting the number of recommendations here to 3 by pretty strict selection criteria, but we could have gotten much more. So when we started the bot, the first thing you saw was that it was being deployed to the local machine. Let me explain to you what that means. All the development and the management of the bots is done in the control room in the cloud. However, the bot itself is run on a separate machine. So that can be a virtual machine, it can be a physical machine in the customer's environment, or it can actually be the laptop of the schedulers. The important thing is the customer can choose where that computing machine is located. So the data that's being exchanged with the freight exchanges here and with the internal system is under the control of the client. It's in their system. So the only thing that's leaving this environment is the signal to the control room to launch the bot and the actual code of the bot itself. However, all the credentials, all the passwords, and all the data, first of all, is securely stored in the credentials vault and encrypted. And secondly, can be exchanged directly between the customer's machine and those applications. So we've seen how a scheduler at a logistics company can optimize their manual processes, their repetitive processes, and their extraneous processes by putting them in an algorithm and having a robot run that algorithm in the background. That massively increases productivity, that makes the job of a scheduler less stressful, and at the end of the day, what this means for the company is more truck utilization and more revenue. So it's really no-brainer to start automating some of the processes that can be automated. And not only is the goal to increase efficiency, but in my view, most importantly, it unlocks new approaches to doing things. So why is it that we have to look at each individual vehicle when we can look at all our vehicles out there and we can look at all the orders out there and find the best possible match within a matter of just a couple of minutes? If that's possible, then why don't we take a truck that's currently on the road at 80% capacity and use that same robot to find an order that's on its way, and with a light detour, it can be picked up and increase that utilization perhaps to 95%. If it's a small order, typically you wouldn't bother picking it up, but if it's en route anyway, and it can be found automatically without any additional effort, then even if it makes, I don't know, 50 euros for the company, why not go for it? If that's possible, then shall we buy more trucks? If that's possible, does it unlock growth for us? If that's possible, can we train our schedulers in a different way? Can we encourage teamwork? Can we provide better service to our customers? So I'm really fascinated by the kinds of opportunities and the kinds of different ways of thinking that are unlocked by introducing automation, intelligent automation into the mix. As an executive, I see it really as an another tool in my toolbox that can be used in addition to my employees and in addition to my IT systems to unlock new ways of thinking, new ways of serving customers, and new ways of increasing profitability and growing. Thank you for watching.